So we're in section 2.5, solving equations using addition or subtraction. All right, example 1, we have 3 equations that we need to solve. So there's a couple tips that we can actually apply when it comes to solving any equation, no matter what the operation is. And that's that we use what we call inverse operations. So we look at the operation that's connected to our variable. So on the side with the variable, what operation do we have connecting to the variable? What operation? Right, so it's going to be addition. So inverse operation means the opposite. Remember we learned that in the previous unit. Inverse is opposite. So what's the opposite of addition? Subtraction. So in order to isolate the variable on one side of the equation, we have to do the opposite. So we have x plus 9 equals negative 3. Did y'all write that down? All right. Inverse operation says we subtract 9 to get it to eliminate. But then our rule says whatever we do to one side, we have to do the same thing to the other side. All right, so now our goal is accomplished that we got x by itself. We can bring it down. And now we have to ask ourselves, here's where our addition and subtraction rules still come into play with integers. What is negative 3 minus 9? So before you answer that, is it same sign or different? Same. So what do I do? Negative. Add and keep. Negative 12. See how that all kind of starts tying together? So we just used a lot of concepts that we've already learned earlier this year and built on it to solve this equation. But we're not done yet. We think negative 12 is the answer based on our math. But now we're asked to check our answer. So negative 12 plus 9 equals negative 3. Well, don't just assume, okay, yeah, it checks out. Actually do the math. You're allowed to use your calculators. This is a great time to plug it in your calculator. Is negative 12 plus 9 negative 3? Yes. Yes, it is. So you'll say negative 3 equals negative 3. Check it out and box it in. All right, and that's how we would complete one of these problems. Inverse operations and then checking our solution. All right, so on the next one, a plus 7 equals 12. Everybody together, what do I do to both sides? I need to subtract 7. I have to do that inverse operation to get a by itself. A equals 5, but I'm not done there. I have to substitute it back in where a goes in the original equation. Is it true that 5 plus 7 is 12? Yes. So I say 12 equals 12 and I check it out. All right, next one. Y plus 5 equals negative 13. What do I do to both sides?
Subtract 5.
Subtract 5 from both sides. Now y equals negative 18. Again, I'm not done. I can go back and plug it in. Negative 18 plus 5 equals negative 13. And yes, that is true. So the beauty of solving equations is I can actually check every single solution. When you go to turn in your next quiz or your next test, the good thing is that you can actually turn it in already knowing what your grade is going to be. Knowing for sure, 100% that you got the answer right if you can check properly. So there's a lot of benefit to that. Moving on to example 2, it's very similar to example 1, except now I have just a different operation. So now instead of addition being connected to my variable, I now have, what operation do you see there? Subtraction. So what's the opposite of subtraction? Addition. All right, very simple. I just need to do inverse operations to isolate my variable. Well, what else do you see that's a little different about the way these equations are written? The total is first, and then my variable comes second. All right, so I can actually change the order of that equation. That's fine as long as I keep the same terms on each side of the equation. So I think just visually, that's maybe a preferred way to look at it. Would y'all agree? Yes. All right, so it's perfectly fine for you guys just to switch that around. Even when you're copying the original problem out of the book, if you want to go ahead and switch it around, I'm totally fine with that. All right, just make sure that the same terms stay on each side of that equal sign. All right, now, negative 11. Well, if we follow the same practice that we did in the last example and subtracted, would negative 11 minus 11 cancel it out? No, it would be negative 22. So I can't subtract. I have to do the inverse operation. I have to add 11. And when I do that, the 11s cancel, and I now have y by itself. So now, what's 23 plus 11? 34. And that's my answer, or so I think. How can I be sure?
Check.
I can check it. Plug it back in. 34 minus 11 equals 23. And don't just assume at this point, oh yeah, it checks out, okay, I'm good. Actually do the math. Put it in your calculator if you need to. What's 34 minus 11?
23.
It is 23, so it checks out. All right, I want you to go ahead and do B and C. All right, so we have 42 equals x minus 15. Again, we have to do inverse operations. How do I get rid of negative 15? Add 15 to both sides, and I get 57 equals x. But I'm not done. I need to go back and double check. And yeah, it's true. 57 minus 15 is 42. So just the substitution is not enough. Okay, yes, you've proven to me you can substitute, but have you actually checked it? Have you actually simplified that 57 minus 15 to make sure that it equals 42? That's the actual checking part. All right, next one. 12 equals a minus 16. We add 16 to both sides, and yes, we get 28, and when we substitute it back in, it does equal out. All right, who got them both right? Anybody get them both right? Okay, good. If you missed one little part, do you see what you did wrong? Any questions? All right, so now moving on to example 3. In example 3, we're writing and solving an equation. I want you to turn in your books to page 90. Let's see, we're on page 91. Page 91 in your books. Horses. So one method to weigh a horse, obviously horses are really, really big animals, right? So we can't just pop them on a regular scale and weigh them. So there's different methods that we can use. One method that the book talks about is you can actually just know ahead of time how much your trailer weighs. So let's say a trailer weighed 2,000 pounds. So you can weigh that on like a truck scale. Then you put the horse inside, and then what it weighs after that point, you can subtract the two and find the weight, right? Okay, so we basically are going to use this whole idea of weighing horses to form an equation based on some other values. All right, so in example 3, it says you weigh a horse using this method, and the weight of the trailer is 2,150 pounds. Then after they load the horse on, the trailer and the horse, the total weight is 3,375 pounds. We need to take this information and put it into an equation. All right, so we all know that what does every equation have? Every single equation has a what? An equal sign. And every equation will also have a variable, like Cameron just said, a variable. So on one side of the equation, I have to have some combination of a number and a variable. And then on the other side of the equation, I'm going to have my total. All right, see if you can go ahead and plug in your total. What would your total be? Plug it into the equation. All right, and what number did you plug in for the total? Guys, what was the total weight? 3,375 pounds is the total weight. Now, some combination over here needs to equal 3,375. Well, do I know the weight of the horse right now? Does the problem tell me the weight of the horse? No. It does tell me the weight of the trailer. And I know the two of them together Addition will give me the total. There's my equation. Okay? You have to have an equation. You have 2 problems like this on your homework tonight. Without an equation, you don't get credit. You say, well, I can just solve this mental math, and I believe you. Okay? These are not overly difficult problems, and we could solve it and avoid using an equation. But the problem is that learning how to set up an equation is just as important as coming up with the answer. All right? So the sum of these 2 gives me this. Now, how would I solve for W? I've set up my equation. How would I solve for W?
Subtract 200.
Very good. Subtract 2,150 from both sides. All right? And then the weight of the horse is 1,225 pounds. All right, setting up an equation and solving. So now I want you to try one. Turn in your books to page 92 and do number 5 on the bottom of the page. You're going to set up an equation and then solve. Without the equation, you don't get credit. So you have to have the equation. Even though you might know the answer right away, set up an equation and solve it using our inverse operations. Okay, what equation did you write? Someone raise your hand and tell me. What equation did you write? Avery?
I put x plus 148 equals 161.
That's exactly what I had, except I just used W for weight. So the weight of the cat, which I don't know, plus the weight of the boy, which I do know, equals the total. So what do I have to do to both sides? Subtract 148, and the weight of the cat is 13 pounds. That's a pretty hefty cat. Pretty decent, 13 pounds. All right, so that's it for writing and solving an equation. You have 2 of those on your homework tonight. Well, we're not done. Not done. Okay, now we have another example. What is this? What shape?
Triangle.
This is a triangle. All right, now it's going to ask you on number 38 on your homework tonight to find the perimeter of, I'm sorry, not to find the perimeter, but to find the unknown side length. Well, we do have to know our perimeter. Our perimeter is 20 inches. P equals 20 inches. Okay. And we also need to know a formula. Does anybody remember the formula for perimeter?
Is it 1/2 BH?
Nope, perimeter. P equals A plus B plus C. What does that mean? Add all the sides together. So go ahead and make your substitutions now. You know the perimeter. Go ahead and plug in all of your values. So we plug in 20 for P. All right, so we say 20 equals X plus 6 plus 10. Did you get that?
Yes.
All right, but now, and you have, I think, you have 3 problems on your homework like this, where before you can actually solve for X and start moving numbers, is there something on this side of the equation that can be simplified?
Yes.
What?
6 plus 10.
6 plus 10, which is what?
16.
16. So now, X plus 16, and I need to put 20 right here. All right, we've got X plus 16. Now, what can I do to both sides?
Subtract 16.
Very good. We don't need the inches there yet. All right, so we subtract 16 from both sides. Subtract 16, and 4 inches equals X. And if you said X equals 4 inches, that actually makes a little more sense. But either way, it's the correct answer. All right, so you have a couple numbers 32 and 34 tonight. You're going to have to simplify on one side before you can move. And then this one is just like number 38 on your homework tonight, just different values. All right, and if you understand that, that's everything you need to know for section 2.5.